Yes. Okay, good morning class.
Good morning, sir.
So today we're looking at the examples for exercise 7.4. These on the next page. Exercise 7.4. And exercise 7.4 is on page 148. And the example is on page 147. Okay. So now today we're looking at sketch graphs, restricted domain, and finding the equation of the straight line. Okay. So looking at this example, as we said, the examples on page 147, we are asked to draw a sketch of the graph f of x is equal to 3 minus x with domain x, domain from negative 3 to 1. Then we got a block and a curve bracket. I mentioned to you before in term 1, what does the block and the square bracket mean? Who can remember what does the block bracket mean? Yes, Michael? Sorry? Sorry? Well, can somebody tell me what she say?
Another bracket.
Another bracket. The block bracket means another bracket. I'm confused. The block bracket, for those of you who forgot, I'm just going to take you back to term 1's work. Remember when we did the number line? Okay, and we said x was greater than or equal to 3. Then 3 was there. Then we had a closed circle. You remember? It was more than 3. Not some, that's your x, whatever. Not your x. So if I must write this as an interval notation, then I write block bracket 3, and it goes all the way to infinity, curve bracket. So what if we have where x is greater than 3? So would it be an open or closed circle? Open. If it's equal to, it will have a closed circle. So if x is greater than 3, it's in that direction. So if I must write that in interval notation, it will have a curve bracket. 3 and it goes all the way to infinity curve. Can you see that, people? So what does a block bracket mean? It's inclusive. It's included. What does a curve bracket mean? Excluded. Now infinity will always have a curve bracket. You guys understand? So if you look at this here, it's going from negative 3 to positive 1. So this is, if I must write this as an inequality, then I would have said x is greater than or equal to negative 3, but x is less than. That's the same if I had to write it as a inequality. You guys understand? So the inequality is now with this sign here, whilst this is called interval notation. So they can give it to you in either or. However, when you state the domain and range, you can give it in whatever format you want to. Okay? You can either give it as an inequality or as this is here. Okay? So if you're looking at the graph f of x, did we do the dual intercept method at this point already?
Yes, sir.
Yes. So what do? We say x intercept. What do you do for x intercept? We let y equal to 0. Okay. So we go 0 is equal to 3 minus x. So x is equal to 3. Now we go y intercept. What do you do for y intercept? Let x equal to 0. So then we say f of 0, or we could have just said y is equal to 3 minus 0, which is 3. Okay. So if I should draw this graph, this is what the graph is going to look like. The normal graph. I'm not considering this restriction yet. I'm going to show you now how it affects it. Okay. So we got minus 3. So x is 3, so 1, 2, 3. Why am I going with this? Because I know it's going to be needed. Is 1, 2, 3, 4. Okay. So if I should draw this graph, it's going to cut at 3. X is 3 and y is 3. No? So So if I draw that graph, it's going to look like it. You all agree with that? But what do you notice here? Here's a restricted domain. Can you see that? So the restricted domain is at -3, which is here. If I go up, 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 it's there. Not so? And it's going to cut at 1. There. Not so? So is this open or closed circle? Closed circle, and that is of course an open circle. You guys understand? So which means to say that that is the graph we're going to draw. Only that part. So what I do is I would draw it in pencil, lightly. Okay, and then just draw darker over the graph. But because we're busy on the board here, you're not going to see the light and the dark. Okay? So what I do is I say, okay, I actually need the corresponding y values here. Can you see that? So what is your x value here? 1. And what's your y value? How do you calculate the y value? By substituting 1 into f of x. So now we say f of 1. What is f of 1? Whenever I see x, I put a? So it's 3 minus 1, which is 2. Can you see it's about the same in line with that thing? Can you see that, people? So there's a 2. On the side here, f of, what's your x value here? -3. So it's going to be 3 minus 3, which is 6. So this is -3 and 6. And this is all my information I need for the graph. So what I do is I need that point, that and that. So if I should draw, this is what the graph is going to look like. You guys understand? So there's our graph. Okay, must I do it again? Alright. Okay, so they ask you to draw the graph of y is equal to f of x, which is equal to 3 minus x. What type of graph is that? It's a linear graph. How do I know? Or a straight line graph. How do I know that? The highest exponent on x is 1. Can you see here the highest exponent? This graph is actually in the form of y equals mx plus c. That means f of x is equal to minus x plus c. What's your m value? -1. What's your c value? 3. Can you see it's in that form? So what type of graph is this? Straight line or linear graph. Okay, so that's number 1. You guys were confused about that as well. Okay? So, because we did the dual intercept method, and the dual intercept method is the method we're going to use all the time, or most of the time. Okay? Since you were exposed to that, that is why I went to go draw this graph using that method. So I said, y-intercept. What do you do for y-intercept? We let x equal to 0. So you say f of 0 equals 3 minus 0, which is 3. Okay, so what I do is, I get the graph. I think I have an axis, yes. Okay, but I won't be able to do much on it. So I went 1, 2, 3, 4. Minus 1, minus 2, minus 3, minus 4. Minus 1, minus 2, minus 3, minus 4. Okay. That's your origin, that's your x and your y. So your y-intercept is x equals 0. You're going to cut your y at 3, which is there. So now we go. X-intercept. What do you do for x-intercept? With y equal to 0. Now we know that this f of x is the y. So 0 is equal to 3 minus x, so x is equal to 3, which is that point there. So what I do is I draw this graph. If there was no restriction on the graph, if this was not here, then that would have been my graph. You all agree with, you all understand? Alright. Now, because there is a restriction on the graph, we know that the graph is going from -3 to 3 on your x. So which means to say the graph gets cut off. Just take it out. See this graph carries on here. Alright. So you see the graph is cut off at -3. And it's a closed circle. Why is it a closed circle? Because it's a block bracket. Can you see that?
Yes, sir.
And you must cut off at 1. And 1 is there. Not so, and the 1 will have a open. So the x value, remember I'm interested in that coordinate there. So the x value is -3 and some y value, and this coordinate is 1 and some y value. And that is what that graph is going to look like. It's going to be a solid line there. Okay. Why? Because it's restricted between those values only. So how do we get the corresponding y value? By substituting -3 into f of x, you will get the corresponding y value. So what is f of -3? So you go 3 minus -3, which is 6. Okay, so there's 6 there. And then we say f of 1. If I say x, I put a 1, so it's 3 minus 1, which is 2. There's that graph. You see that, people? Now because this graph is light, you just draw a dark line over that. And there's your graph there asking you to draw. Okay. So that is the A part of the question. Let's look at B. B says, write down the domain of this graph, the range of this graph. So what is range? All possible y values. Now we always read the range from negative infinity to positive infinity. Likewise with the domain. Domain you read from the negative infinity to positive infinity. Okay? We always read it from left to right or from bottom to top. Okay? From negative to positive. So from the bottom, does this graph exist at negative infinity on your y? How do I know it's the y they're talking about? They're talking about the range. Range is y values. Okay? Does this graph exist at negative infinity? No. Where does this graph start existing at? 2. Can you see that? And it goes all the way to 6. Can you see that, people? It's going from 2 to 6. Is that the continuous? Is it together or is it apart? From 2 to 6. From 2 to 6. It's together. Can you see that, people? So because it's together, I write it as a continuous inequality. Okay? So we always write the more negative one first. So 2. So we say x must be, y, because that's the range. Y must be greater than 2, but it has to be less than 6. Now, at 2, is it an open or closed circle? Open circle. So that is why I have y is only greater than 2. At 6, is it closed or open? Closed. So it's going to have an equal sign. So here we say y must be greater than 2, and y must be less than or equal to 6. That's one way of writing it. Otherwise you can say, or y is an element of 2 to 6. Now would 2 get a block or a round bracket? A curve or block? Curve. Why? It's excluding. The 6, block or curve? Block. And there we go. Either one of the two. Either in inequalities or interval notation. Okay. So in the first term when we did this, and you didn't take note, here's it coming up again, and it's going to come up often now. Okay. And if you had a problem with it, go back in the textbook where it was answered, go watch the videos again from the first term, you should get it sorted out from there. Okay. So let's look at example, the second example. Okay. This is also on page 174. Example 2 on page 174. It says calculate the equation of the straight line through -2 and -1, 1 and 2. So we got negative 2, we don't have to draw this graph. So the question was not to draw the graph. I'm just drawing it to illustrate to you what's happening here. Okay. So some visual of what's actually happening here. So it's a line going through these values, these points. Why didn't I draw it only between those points? Because it didn't say that the line is lying between those points. No. Okay? They just said the line is going through those points. You guys understand? So, where do we start? How do we calculate the equation of straight line? We've done this in grade 9. Y is equal to mx plus c is. That's where we start. Y is equal to mx plus c. How do you calculate m? Changing y, we're changing it. Okay, this you seem to know well. So it's going to be y2 minus y1 over x2 minus x1. Okay. So if I make this x1, that will be y1. If I make this x2, this will be y. Did you guys do analytical geometry yet? Okay, that explains it. Okay, so this is exactly what we did in analytical geometry. We're doing here again. Okay. So if I make this x1 and that would be y1 and then of course x2 and y2. You all understand that? So let's go. y2 is negative 1 minus 2 over negative 2 minus 1. So that's negative 3 over negative 3, which is 1. Now some of you are going to say, but what if I had gone the other way around? What if I made this x1 and y1 and that x2, y2? Let's see what we got. So you go y2 minus y1 over x2 minus x1. So it's 2 minus 1 over 1 minus minus 2, which is 3 over 3, which is 1. You see, it's the same. So provided you didn't make a mistake, you should get the same gradient out. You guys understand? Alright. So, have you answered the question? No. So we only got the gradient so far. So therefore my equation now reads y is equal to 1x plus c. Now c is normally a y-intercept. Do I know for sure what my y-intercept is here? It looks like 1. But are we 100% sure about it? No. It wasn't given to us. In mathematics we don't assume things. Okay? We don't assume we know the things. No? We must study, and for those of you who don't study, you must know where it landed us. Okay? So what do we do with this, people? We can substitute any one of the two coordinates in. Not so? So let's go with the positive one. So we substitute 1 and 2. This is x and a. So we say 2 is equal to 1 times 1 plus c. So c works out to be 1. So what's my equation? Y is equal to x plus. Okay, and that also confirms now that the graph is actually going through a y value of 1. You guys understand? But if you just wrote c is equal to 1, you would have lost the mark. Because then you assume. Okay, we need to see this calculation here. Okay. For us to award you that mark. Okay. Unless they tell us the graph is going through the y-intercept of 0 and 1, or the graph is going through 0 and 1, then we can give the mark. Why? So we told you. Okay. Will any confusion here? No. So with that you should be able, must I do it again? No. Okay. So we did it in analytical geometry. So with that you should be able to do exercise 7.4. We'll stop the video at this point. And then we will look at 7 point.